Okay, second video for the 6 weeks is over circuits and Ohm's law. Some components you need to know about: the voltage source, or the battery. It's going to be where all the power comes from. Conductors, those will be all your wires, connectors, which also count as resistors because there is a slight resistance in everything. And then your control element, switch, volume, whatever it is that you are controlling. Here are some symbols you will need to know when you draw your schematic diagrams. That's just a plan that shows where everything goes and how everything is connected. Notice these are the ones that you will be asked to draw most frequently. So make sure you know those and know how to draw them. This is what a schematic diagram would look like. You have your battery, positive, negative, your resistor, and your switch. And remember, current always goes from positive to negative, only if the switch is closed. You have to have a closed circuit for there to be a flow of electricity. Key terms from the previous PowerPoint: resistance, current, and voltage. Again, those terms will be important. Make sure you know them. And why is because of Ohm's law. The current through a conductor between 2 points is directly proportional to the potential difference across the 2 points. What that is saying: the current and the resistance or the voltage are directly proportional. One goes up, the other goes up. So this is what a graph would look like. The resistance is constant, which means these two are directly proportional. Some other ways you can look at this: current equals voltage over resistance. Voltage equals current times resistance. Those are 3 forms of the equation that you will need to use. Here's an example asking you for the resistance. Current is 3, voltage is 15. Work that out. We'll talk about that in class. The other equation is electrical power, which is just voltage times current. So if you have voltage and current, you can find the power transferred by the circuit. Here's an example for that. Work this out, see if you can get the correct answer. We will discuss it in class. Some more vocab. Equivalent resistance. This is just a fancy way to say total. Hence resistance total. Voltage drop. That's how much the voltage will decrease each time it passes a resistor or a light bulb or anything that's going to use up electricity. 2 types of circuits. First one's a series. Notice there's a single loop, so there's one path for this electricity to flow. It cannot change direction. It just goes one way, always from positive to negative. The current is the same in each element, and the resistance is the sum, so it'd be R1 plus R2. So this is in series. You add them up. Here's an example. You have a 12 volt let me scoot this over for you real quick. There you go. Okay, you have a 12 volt supply, 2 ohm resistor, and a 4 ohm resistor. So first you'll have to draw your schematic diagram. Make sure when you draw these you label them: 12 volt, 2 ohm, 4 ohm. and then find the total resistance. Parallel circuits, multiple paths. So I could have the electricity go this way, or it could keep going and go this way. So there's multiple paths for the electricity to follow. The current changes to different resistors. So each resistor is going to have a different current. The voltage is constant. And to find resistance, it's 1 over resistance total equals 1 over R1 plus 1 over R2. So whenever you find this answer, say it's 5, no, that's 5 to the negative 1. You have to take the inverse of that number to get the actual resistance. Here's your problem again. You have your 12 ohm power source. There's my 2 ohm. There's my 4 ohm. And here's a comparison. Series is a single, parallel, multiple. Voltage drops add. Voltage is the same in each branch. Current is constant. Currents add up. Total resistance is the sum. Total resistance is smaller than the smallest resistor. Don't forget to take the quiz. And have a great day.